Hi, I'm Sam Roberts for Roberts Geospatial Engineering. Today I want to talk to you about my software on ARM-based CPUs. So I'm on the ProRaster Scientific product page. Go to my website robertsgeospatial.com.au to find out about ProRaster Essential, ProRaster Premium and ProRaster Scientific, and then you'll find a link there on those pages that will take you to the Microsoft Store where you can purchase the software. But today I'm going to talk about ProRaster running on ARM-based CPUs. So I just have a little slideshow here. I'll just start. Okay, so if you've bought a PC in the last few years, you'll have one of two possible CPUs in it, or two possible CPU architectures, I should say. The first one is x64. So this is going to be found in any Intel CPU or any AMD CPU. In fact, AMD created the x64 microarchitecture, which evolved from the old 32-bit x86 architecture that, of course, we had back in the old days and was owned by Intel. So you'll find that in most PCs today. The second architecture that you'll find is the ARM architecture, and it's completely different. So the code between x64 and ARM is completely incompatible. One cannot run on the other. So you'll find these Snapdragon X Elite chips in laptops at present, and various other Snapdragon chips, and they're in your Copilot Plus PCs, which Microsoft have been marketing and pushing very hard. So if you have a Microsoft Surface, for example, or Surface laptop, you probably have one of these Snapdragon ARM-based CPUs in it. If you have an Apple PC with an M series CPU in it, that is also based on ARM. So there's our two kinds of CPUs, and they don't talk to each other, right? Code for one does not work on the other, and vice versa. So as a developer, that means I have to build different configurations of my software to run on different CPU architectures. So let's talk about what those build configurations are. Specifically for ARM. So the first is ARM64. So this is native code, and this is where you want to be. This is what you're aiming to produce on a ARM-based PC. It will give you best-in-class performance and best-in-class stability. And when you run Windows on ARM, you can go to the task manager and you can look at the architecture column, and you'll see that almost everything that's running is ARM64, though occasionally you'll see some other processors and applications running that are not ARM64. So what are they? Well, the next build configuration that you can use is x64. Now, x64 code is not compatible with ARM CPUs. So what happens? Well, it's emulated. So Windows on ARM ships with an emulator, and when you double click on an x64 executable and it runs for the first time, the emulator will fire up, and there'll be a delay, sometimes of several seconds, whilst it goes through that x64 code and converts it directly into ARM64 code. It must cache that code somewhere, and thereafter it will run that ARM64 code. Now, the problem with this is firstly lower performance. Usually not an issue. In some specific applications it is an issue, but for me that's the lesser of the evils. The real evils are firstly that there seems to be poor stability of emulated software on ARM. In other words, it will crash quite frequently and quite sort of randomly. And secondly, the software simply may not run at all. And when this happens, you get no clue. So you can click on your executable to run it. It will go off to the emulator to try to convert the x64 code to ARM64 code. It will fail to do that because there are x64 instructions in that executable that it cannot emulate. and then it will just simply die, and it'll give you no message, just nothing happens. It just goes away and doesn't run, and so that's a pretty poor outcome. So that's the x64 emulated configuration. There is a third way, and this emerged last year, and it's called ARM64 EC. So in this configuration, you build for ARM64, but you can call functions in libraries that are compiled in x64 and delivered in x64 code. So this is a hybrid native and emulated model. Couple of things to note. Firstly, the ARM64 code that it builds is not actually ARM64 code and is not compatible with ARM64 code. It is native code, but it's different. There are technical differences between the ARM64 EC native code and ARM64 code that prevent them from being compatible. So you can't use ARM64 libraries in an ARM64 EC build. You can only use ARM64 EC libraries and code and x64. So ARM64 EC gives you improved performance over emulated x64 code. It certainly gives you improved stability. I've noticed that is a major improvement. And the problem is support is only beginning to emerge for this configuration. So it is a fairly new thing, and it's just not all there as yet. So let's look at ProRaster on ARM. So let me go through the three options. So firstly, an ARM64 build. Well, this is what I'm aiming to provide customers because it's best in class. My problem is that I have two libraries for which I do not have code, which I cannot build myself, and for which I do not have ARM64 binaries. So I have to rely on those vendors who provide those libraries to build them for ARM64 in the future and supply them to me. That will almost certainly happen, but I can't tell you when. It's entirely up to those vendors. So currently, ProRaster using ARM64 is not available. ARM64 EC. So I've been down this rabbit hole, and I have produced an ARM64 build, and I've tested it on a Snapdragon X Elite laptop, and it works very well. It's great. My problem is that it is currently not in the Microsoft Store, and I can't currently deliver it into the Microsoft Store. So there's a gap in the functionality for the Microsoft stack. They've provided all the libraries, they've got everything working, but they haven't provided you the ability to build the package that goes up to the store that you then download and install on your PC. So ARM64 EC is not currently available. As soon as Microsoft resolve that, fill that gap, resolve that problem, I will build an ARM64 EC configuration and I will upload it to the store, and then you'll be able to run ProRaster on ARM-based CPUs. But at the present time, the only configuration I can supply is an x64 build. So if you've got an Intel or an AMD CPU, you're all good. If you've got an ARM CPU or you've got an Apple M series CPU, you're not good. It is going to be unstable, and ProRaster Scientific does not run on ARM at all. So let me just explain that briefly. ProRaster Essential and ProRaster Premium will run. They will be emulated, but they're quite unstable, and I've noticed them crashing quite a lot. I think it's mostly due to graphics drivers, and I think that that's recently just been improved. But even so, I can't recommend that you run those applications on ARM. ProRaster Scientific uses superscalar instructions. So it uses something called AVX2 that Intel dreamed up, and AVX2 is not available. There's a similar thing, it's called Neon, but AVX2 is not directly compatible with ARM. So the Microsoft emulator currently will not emulate AVX2 instructions, and so ProRaster Scientific simply doesn't run. Now, this will probably change because a year ago in 2024, Microsoft announced that they had added AVX2 emulation into the emulator, but they only made it available in the preview build and for certain applications, and a year later it is still not broadly available and it doesn't work. Now, surely that will change, but I can't tell you when. Excuse me. And just one other issue, and I don't know all the facts around this issue, and it's so difficult to find out. But 10 years ago, if you bought a multi-core CPU, you would get like 4 cores, and each one of those cores would be identical and would run the same instruction set. Today, when you buy a multi-core CPU, if you get an Intel CPU, for example, then you will get a mix of performance cores, efficiency cores, and low-power efficiency cores. If you buy an AMD, depending on the CPU model that you buy, you may get what are called big and little cores. So the big ones are efficiency cores, the performance cores, and the little ones are efficiency cores, effectively. Snapdragon currently has all identical cores, but in 2026, when they bring out the next generation of Snapdragon CPUs, I believe they will have performance and efficiency cores. And then there's the issue of consumer versus server CPUs. So there are differences between consumers and server CPUs and the technologies in them. Now, with regard to something like AVX2 that I use in ProRaster, it's available in your Intel performance cores. And I believe that it's available in the efficiency and low power efficiency cores, but I'm not sure that it has been available through each generation of the Intel CPU. So there's a question mark around the 12th generation CPUs, for example. I'm not sure that the efficiency cores in a 12th generation Intel CPU support AVX2. And so if I run ProRaster on one of those CPUs, I do ask the question, I wonder, if an AVX2 instruction in a thread is executed on an efficiency core on a 12th generation CPU, will it crash? I don't know the answer. I don't know how to find out the answer apart from testing and on the actual hardware. And but there's a question mark over it. So there's just this additional issue, more complications, not only in the entire architecture, but in the cores themselves, and in what is compatible from one core to another. So just in summary, ProRaster is currently not compatible with ARM CPUs, so I cannot recommend it. I do not recommend ProRaster on an ARM-based CPU, whether that be a Microsoft Surface with an ARM CPU, or a Lenovo or something with a Snapdragon CPU, or whether it's an Apple with an M series CPU, running Windows on ARM through Parallels. But I am working to address this. Firstly, with an ARM64 EC configuration build, which I hope will become possible soon. And then, as soon as I can get those libraries built with those additional third-party libraries that I require built with ARM64, then I can go to a full ARM64 build, which of course is best-in-class solution. So that's the current state of play for ProRaster on ARM at the 16th of October 2024. Thanks for watching.